Okay, so we're going to call this add and subtract in scientific notation. So in your notebook, up in the upper left, let's just say add and subtract in, I'm just going to write SN. Okay, I'm already up to page 12. Okay, so we're just going to follow what we just saw in the video. Okay, and here's one example. Let's see what we picked up from the video we just saw. I'm going to write 4.2 times 10 to the 6th power, and let's subtract away from that 3.9 times 10 to the 6th power. Okay, so that's what we're going to start with, just a little subtraction. Remembering what we learned in the video, if we have, for example, the powers of 10, if the exponents on the powers are equal, then we can just add or subtract. So I'm just going to write that down. Since this is our notes, we want to make sure to say that. I'm going to say as long as the powers of 10 are equal, comma, add or subtract the coefficients. Remember, the coefficients are the numbers with a decimal usually. Okay? So would you agree here all I have to do is add the 4.2 and the 3.9? Or subtract them, I'm sorry. We're going to subtract them. So I'm going to do 4.2, that's the top number. And then I want to subtract away 3.9. So I get to practice a little decimal subtraction. Looks like I have to borrow, right? I can't take away 9 from 2. So I'm going to make that a 12 by borrowing. So make this a 3. And we borrow to make that 12. And now we can subtract. 12, take away 9 is 3. 3, bring down the decimal. I won't forget that. 3 take away 3 is 0. So I get 0.3 times 10 to the 6th power. So this is kind of like what we saw in the video, right? I can't have 0.3. I need a non-zero digit in front of this decimal point. So let's move this one place to the right. What's that going to do to our exponent? Subtract it. So we move one to the right, so it subtracts one here and there. So that becomes 3.0 or just 3. You can write it as 3 times 10 to the 6, take away 1, which is 5. And that is our answer. 3 times 10 to the 5. So the next two examples, we're going to have to adjust our exponents so they're equal. Okay? Let's practice that. I'm going to move this up a little bit so I can see the next example, number dos. Okay? So the next example, we'll do addition. We're going to have 6.5 times 10 to the 8th power plus 3.1 times 10 to the 9th power. So we're adding two of these, right? But our exponents aren't the same. We have 10 to the 8th, 10 to the 9th. Which one is, should we, let me just phrase it this way. Should we change the 9, bump it up to an 8? Or should we change, should we change the 8, bump it up to a 9? Or change the 9 and bring it down to an 8? Which one is better? 8. You always want to go from the lower power to a higher power. The reason for that is you're going to push the decimal to the left. If we would do that, if we change the 8 to a 9, that moves the decimal to the left. However, if I would have changed the 9 to an 8, that moves the decimal to the right. So instead of 3.1, I would have 31. And then I would have to do another adjustment later on. So the better thing to do is always make the lower exponent a higher exponent. I'm going to write that down. Make the lower exponent a higher one to avoid. It won't always cause it to avoid this, but 80% of the time at least it will. To avoid fixing answers at the end. If you do what I'm just suggesting, take the lower power, bump it up to the higher power, and by bumping up, we want to add 1 to make it 9. Okay? It's going to help us. So if I want to make that a 9, that means I have to move my decimal one place to the left. Right? So now let's see what that would give us. This is no longer 6.5, it's 0.65 times 10 to the 9. So this is not what we're working with. I'm going to put a 0 there, by the way. 0.65 times 10 to the 9. So now we have the same exponents, if you notice. We have a 10 to the 9 here, 10 to the 9 there. We can do addition with those numbers. So that's what I'm going to do next. I'm going to add those numbers. 0.65 plus 3.1. And I'll put a 0 there as a placeholder. And let's see what we get. That's 5. 6 and 1 is 7. Bring down the decimal. 0 and 3 is 3. 3.75. So I'm going to end up with 3.75 times 10 to the what power? 9. Now, if we would have changed the 9 to an 8, the number would have been too big. We would have had to move the decimal point to the right, and then that would have changed everything. We still would have ended up with this answer, but it would have been one extra step. Okay. Any questions? Okay. So we're going to move on to another example. I'll just push this up so you can still see it. But I'm going to write in the third problem. Okay. Let's do a subtraction. And this time, we're going to have to do an adjustment with the powers. So let's go. 5.7 times 10 to the negative 4, take away 9.2 times 10 to the negative 6. Okay. So let's take a look. The powers aren't the same. So we have to go with a smaller number, the lesser number. Think about the number line on the negative end. Which number is smaller, negative 4 or negative 6? Negative 6. So we want to change this one. Okay. So if we want to change that, we want to add 2 actually, right? Because negative 6 plus 2 is negative 4. That means we have to move how many spaces to the left? 2 places, because we're adding 2. 1, 2. This is where the decimal point goes now. So that's going to give us this number. Decimal point 0.092 times 10 to the negative 4. And I'll put a 0 there. So this is no longer what we're working with. We're working with that one. And the reason is we now have both our numbers with the same negative 4 exponent. So we can just take away. We're going to do 5.7 take away 0.092. So I'm going to do that math now, okay? So let's do that. 5.7 is the top number. And I probably want to add 2 more zeros behind that for placeholders. And then take away 0.092. Okay? Oh yeah, remember when you used to do those? Well, here we are again. Well, let's subtract. 0 take away 2. Well, the problem is, if it was 2 take away 0, yeah. I got to do some borrowing. I got to borrow here. I can't do 0 take away 2. I got to borrow from the 7. 7's going to be real generous. It's going to become 6, right? We're going to give 1 to the first 0 in the hundredths place, making it 10, but then he's going to be generous. We'll borrow 1 from him to make it 9, and then give that to the thousandths place, make it a 10. So now we have 10 take away 2. And that we can do. That's 8. 9 take away 9, 0. 6 take away 0. Well, that's a subtraction we can do. It's 6. Bring down the decimal. 5 take away 0 is 5. It's 5.608. So I think we have an answer. 5.608 times 10 to the negative 4 power. So subtracting these two numbers gives us this value. Okay? Any questions? All right. No questions? We'll do the last example then. Número 4. Okay. So in this example, this is going to be another science-related word problem. So it turns out, and this is coming from chemistry, if you're In chemistry, you work with different combinations of chemicals. And it turns out, you've seen the experiments where they pour in a certain amount and then all of a sudden something starts bubbling up. That's what you call a catalyst. That's where when a reaction starts. And you need a certain amount of whatever chemical in the solution for that to happen. And so this is going to be a question like that. So here's the question. A solution contains 5.6 times 10 to the, oh, no, sorry, that's not the amount. I changed the amount. Let me fix that. It was 9.6 times 10 to the negative 4 liters of benzene, and that's a type of chemical. To create a reaction, an additional 8 times 10 to the negative 5 liters of benzene are needed. Here's what we want to know. How many total liters of benzene must be added to the solution? So that's the question we want. So we're going to start off with this many liters. We need an additional 8 times 10 to the negative 5 liters. So we want to know how many total liters should we add. Just by hearing the word total, does that mean we add or subtract these numbers? Add. Yeah, look for keywords there. And this one definitely, when you total something up, you add it. Okay? So let's add these numbers. Okay? So we're going to take our starting amount, 9.6 times 10 to the negative 4, and we're going to add to it 8 times 10 to the negative 5. And let's see what happens. So same as before, powers of 10 aren't the same. We either change negative 4 down to a negative 5 or negative 5 up to a negative 4. Yeah, negative 5 to a negative 4, because that's a smaller number on the negative side of the number line. So we want to just basically add 1, right? So here's our decimal point. Is it going to go 1 to the left or 1 to the right? 1 to the left. It's going to go there. It's going to become 0.8. Okay? So our new number is 0.8 times 10 to the negative 4. Okay? Because now we have both of these as 10 to the negative 4, and we can add those. So let's go ahead and add 9.6 and 0.8. 9.6 plus 0.8. Okay. These 6 and 8. That's what? So we gotta carry one over. And then that's 10. So I get 10.4. 10.4 times 10 to the negative 4. What's the problem with 10.4? It's too big, right? We gotta move this decimal one more place to the left, which means, remember, you add one here. So we gotta do negative 4 plus 1, which is 1.04 times 10 to the, what's negative 4 plus 1? Well, same sign, add and keep, different sign, subtract. What's 4 take away 1? It's going to be 3, but it's going to be negative 3. So negative 4 plus 1 is negative 3. So it's 1.4 times 1.04 times 10 to the negative 3 liters is the amount that's needed. Okay. So this is the amount of solution of that benzene. We're gonna need 1.04 times 10 to the negative 3 liters. Okay. Any questions? All right. So on today's assignment, you're going to have IXL. You won't have word problems. Tomorrow you will. I figured we'd get one done today.